Hey, just wanted to give a quick intro into the video series slash streams that I'm going to be doing in the coming future. They're basically just going to be my learnings and understandings, and basically just like me building a game in Roblox, which is something that I've always wanted to do ever since I was a kid. So it should be a lot of fun, should be a lot of good brain teasers and puzzles to get through. But hope you join me on my journey. And I'm Jeremy. So yeah. All right. So the first thing I kind of want to do is give you a rundown of what I want to build and kind of what I foresee the world looking like and what I want my final game to really become. So uh, the title is Slime Wars, and what I kind of envision is, you have a team of, I don't really know how big the servers allow these days. I think it was like eight, maybe back in the day, but I kind of foresee it being a small to mid-sized server where you work as a team against basically a never-ending, like increasingly difficult wave of slimes that basically spawn and try to attack your slime pumps. And what these slime pumps do is uh, basically, pump slime, which you will use within the game to buy weapons or maybe get upgrades, build barricades, whatever. It doesn't really matter. I'm really in my early stages, but that's kind of the at least gist of it, right? Players will be working together to fight waves of slimes coming in that basically want to destroy this, or probably these. I might have some scattered around. I don't know. Slime pumps. And probably wondering, what is this thing that is just obliterating me around the map? That is like an XP particle that I've been working on that basically will be coming out of these pumps, or it's more like I haven't decided what it's going to be. And I still need it to, give me a point and disappear once it touches me. So, but for now, it just smacks me around. So I'm gonna go ahead and probably jump into some more technical aspects of what is making this particle follow me around and what I think my next steps are going to be. So the next thing I wanted to talk about was basically what I did to get that particle to follow me around and what I envision kind of the next steps with it to be, and at least where I am with it. So the first things first, I had to, build the actual model for it, right? Which kind of boiled down to um, a, piece in the middle here. Well, hold on. So, a piece in the middle here that is the actual particle itself. And then what I made was this union being like a hollow sphere to fit the particle inside. I can actually make this untransparent for you, right? And you can see if I zoom in here, it has like this negative piece that I had to union. Spent more time than I'd like to admit trying to figure that out. But this is basically its influence sphere, because I didn't want to have a script running, every time to be like checking if a player was within 15 studs of a particle or not, right? I want it to be like I want everything to be event driven, right? And having physical renderings allows for that, at least in my theory, or at least how I envision it. So let's get into the handler, and I'll break that down for you guys. So yeah, getting into the handler, um, I think it'll be a bit more useful to start looking at the influence sphere handler, kind of because it's the thing that gets everything in motion, right? Player walks into the influence sphere, you get touched, and things start really moving, literally moving if you're the particle. So, um, right, we have a hit. This is the whatever basically contacted our influence sphere, right? And so for us, we want to check if it's a player. And we use some built in services and functions to basically determine if this hit was a player or not. And we can do a check to see, if the player exists, i.e. we touched a player. And then we can say, hey, our target player is this player, right? And so that kind of gets things in motion. And when I say get things in motion, then we can kind of start looking at this run service thing here. And what this run service dot stepped, like what you're listening to here, is sort of Roblox's built-in, I guess like FPS timing function or update or stepper basically. And you can use this to at least very efficiently handle, and they give you a delta time between frames, and it takes your client to um, process each frame. And so you can use that to make very fluent and, I guess, well responsive, if you will, physics. So that's kind of what I did here to begin moving the particle. And I'll stop it here and break it down for you guys if you don't have a crazy understanding of vector math. All right, so the next thing I wanted to do is kind of break down these couple lines of math for y'all and give you an idea of how it actually moves our particle throughout the world. So um, first things first is I kind of frame the problem as, P0 being our player position, right? The position that we want our particle to be in to award that point. And then other part of our kind of problem being P1 is the particle position, and the position you want to change to P0 so that the particle can touch the player and you can get a point. So I'll link some math down below, but basically these next two lines are what do all that magic. And to give y'all kind of an idea visually of what's happening, I put together this little sketch. And so what's kind of going on, right, is we have this P0, that is where our player is. We have this P1, where our particle is. And we just want to determine, right, a vector that points from our particle to our player and then assign that to the velocity with some magnitude, right? And so those next two lines basically achieve that by taking the difference of the two, right, which would essentially give you a an arrow that points from P1 to P0. And then I make it a unit vector, essentially 1, and then I give it some magnitude here. And that is what is driving the particle to move, right? It's this assembly linear velocity, right? We're setting it equal to a vector with some magnitude, if we have a target player every FPS change. And so I don't know if this is the most efficient way to do it, but for now it works. And I want to clean it up a little. I know that I can use this delta time to make it, an acceleration instead of a direct like changing of its velocity. Like it would be less jerky if I could, abuse this delta time, make it feel more like a force, and I think it would be a lot smoother. But for now, this is what the math is, and I will kind of leave it there, and I'll probably get into kind of where I want to go next with this UI handler that's teasing up here. But for now, that is the particle handler. So I know I got a little ahead of myself. I wanted to hop into the UI handler, but completely forgot or at least one of the most important parts of the particle being, when it actually touches the player. So that, of course, is handled in this part that I forgot. We already talked about the touch listener and, what kind of goes on with the hit and how we determine if it was a player or not. But what we would need to talk about, right, is how we actually are giving the player a point in our game handler. So what it kind of boils down to is this slime ball touched function. And what this slime ball touched function is, it's called a bindable function. And essentially what these are synchronous ways to send data back and forth between different scripts. So it allows me to send, hey, this player touched a particle to the game handler, right? And basically both of these kind of get a reference to the function via this call right here, this get service. And so, with each of them, one being the, event fire and one being the subscriber. And so in this case, our particle handler is invoking or firing, this player touched us. And so then we can hop into the game handler to kind of understand, okay, well, now how does our game handler kind of handle this in invocation? And so first thing we do, right, is we need to write the function that updates our data. So first thing I did was define an empty dictionary to be our player data. And then we kind of hopped into this if statement logic here where we check, if we already have the player in player data, right, then we could just go ahead and give them one more point. And this is some stuff that I'm working on. And then, otherwise, the player is new, just picked up a slime ball, whatever, give them 0. And honestly, I'm probably going to put this out into like a, on player connected. But for right now, I can kind of give you guys an idea of how this works. So I'll go ahead and show you. Oh, I think I needed to add a, first of all, I need to move, actually, hold on. I'll show you guys, but let me move a couple things around. So yeah, to give you guys an idea of how the bindable function is kind of updating our player data and giving us a point, I want to talk about our pump handler first. So what this is kind of doing is just cloning as a slime ball and then kind of shooting it out the top of it just in a random direction for us to go and pick up. So that's pretty simple. But I just wanted to give you guys an idea of like what is actually generating the slime balls for us. So without further ado, I can go ahead and hop in and you can see that we are printing our player data right there. And I'll go ahead and click play. And so hopping in here, right, we see that it is pumping some slime balls out, shooting in with some random velocity. And once we walk over here and start picking them up, we could see that Steelers Tech is starting to gain some points. So that is awesome. We love that. But one thing you might notice, you're like, hey, they aren't coming towards you, right? Like, that's not cool. Like, why aren't they doing that anymore? Don't worry, that is definitely something I have noticed as well. It is actually has to do with their, I could show you, basically, the union is not getting properly copied where I'd like it. So, like, I wish I could show you under the map, but basically, right, we have the particle and then we had the influence sphere around it. It's basically placing the particle on top of our influence sphere instead of inside of it. So it just has to do with my cloning and positioning of the particle on clone. But something to clean up and something to just keep in mind. But for the most part, working just fine. So yeah, I think we're gonna hop into some UI stuff next. So the next thing I wanted to get into was updating a like user interface or like HUD for the player. So what I envision, right, is maybe like a health bar down at the bottom, ammunition if you have a gun, some other things, whatever. But at the end of the day, right, it's going to be a UI that I'm going to need to dynamically update. So what I wanted to do was start with a simple example being your points, right? And so at this top left here, I am basically creating a small label in your starter GUI. And then I plan on, attempting to update it when our player data updates. And so that was kind of the idea behind these update UI invokes, right? You've already seen a bindable function, right? We're just kind of binding a UI handler to our player data and saying, hey, we want to update our UI, invoke that with this player data. I don't know if this is the most efficient way to do it. I was doing some reading, saw that they were like, hey, you should have a buffer on the client side that maybe sends data to the server every so often. That way you're not, you know, overrunning the server with these synchronous requests. I don't know, you know, I'm just making the game, right? Got to kind of find out down the road. So for now, we're sending play data via these bindable functions, and you'll see my UI handler here, right? All I'm trying to do is just set the text of this label dynamically. But that's kind of where I am, and that is probably issues for another day and another video. So I will see you guys later.